Now we have some practice problems that are like assignment problems. First of all, assignment problem number 2 and number 3. We're looking at tables of values representing ordered pairs, and we want to know, do these represent one-to-one functions? So what we want to remember is that a one-to-one function has a relationship of just one x with one y. So for every y value, there is only one x value. There's no doubling up going either direction. All right, so if we look at this first table, we'll call it table A. We've got negative 2 going to 25, negative 1 to 39, 0 to 20, 1 to 11, 2 to negative 16. There is no repeats of y's. Okay, so that means for every y value, it's only going to one x value. Now let's take a look at, we'll call this table B. So for negative 2, it goes to 10, negative 1 goes to 2, 0 goes to 10. So here's a case where we have y of 10, and we have two values of x that go to that one value of y. So it's being doubled up on, and so this one does not represent a one-to-one function. Okay, for this next one, we want to find f inverse of x for the function f. That is, we want to find the inverse function for the given functions. So this and the next two are like problems number 8, 9, and 10 on the assignment. And I've listed there the 4 steps that we take to write down the inverse function. So first step is just a notation change. We're going to rewrite, instead of f of x, we use y. Second step, we're going to switch the x and y. Third step is to solve for y. So we're going to get y equals 1/3 x minus 2/3. And then finally, the fourth step is, again, just notational change to put that in the f inverse of x notation. So f inverse of x is 1/3 x minus 2/3. All right, on another note, the domain for both f of x and its inverse, well, and the ranges of both of them are negative infinity to positive infinity, because those are linear functions. All right, here's another one. Find the inverse of f of x equals square root 3x plus 2. So for the square root function, we want to identify domain. And also range. So to find the domain, because we have a square root, we want that thing underneath 3x minus 2 to be greater than or equal to 0. So we solve that for x, and we end up with x greater than or equal to 2/3. So in interval notation, we're going to have 2/3 with brackets to positive infinity. All right, we want to write down the range as well. Well, because this is a square root function and there's no vertical shift up or down, or it's not reflected over the x-axis, the range is 0 to infinity. Okay, now that's going to become important because when we find the inverse function, we'll want to identify the domain and range. So our first step is where we're just going to do that notation change, y equals square root 3x minus 2. And now we solve for y. Or no, I'm sorry, we switch x and y. So we get x equals square root of 3y minus 2. And now is where we solve for y. And to get y out of the outside of the square root, we need to square both sides. So we end up with x squared equals 3y minus 2. And then we're going to have 3y equals x squared plus 2, and y equals 1/3 x squared plus 2/3. The fourth step is to just rewrite using the function notation. So we get f inverse of x equal to 1/3 x squared plus 2/3. Now, we know that we need to have a one-to-one function here. It's a quadratic, and it's a quadratic that opens up, and, you know, a quick sketch, that's not going to pass the horizontal line test. So we need to restrict the domain so that it is one-to-one. Now, this does not take a whole lot of working out because the range of the original function is the domain of the inverse function. So we can just copy down what we have for the range of our original function, and the range of the inverse function is going to be the domain of the original function. One more example of finding the inverse function. This time we're starting off with a function that's not one-to-one, right? 4x squared minus 3 quadratic. It has that parabola shape. It is not going to pass the horizontal line test. So that's why we have to restrict the domain to just positive and x values and 0. All right, so we want to keep that in mind. Let's also determine the range of this function. So the range is we're going to be able to get that from the vertex. Okay, so we know this is a parabola that opens up. The lowest point, the minimum point, is right there. And we can figure out what the y value is of that minimum point by using our what we know about transformations. So we see that we have that x squared, and we're subtracting 3. So that means this is a shift down 3. And so I'm not sure what the, so the x coordinate is going to be 0, and the y coordinate of that vertex is a negative 3. So that tells us that the range is lowest value of negative 3, positive infinity. Okay, so now let's go through the steps for the inverse. So step 1, we're just going to switch that f of x to a y. Step 2, switch the x and the y. And step 3, this is the heart of it. We want to solve for y. So we're going to take 4y squared equals x plus 3. We add 3 to both sides. And divide both sides by 4. So we get y squared equals 1/4 x plus 3/4. And then finally, we get y equals, we're going to take the square root of both sides. All right, and plus or minus, we got to remember that out in front, and then we're going to figure out, well, which one of those is actually going to be the legit one. 1/4 x plus 3/4 underneath the square root. And now we have the last step, just the notation change. F inverse of x equal to the square root of 1/4 x plus 3/4. Now we want to look at domain and range. So we know that the domain is just going to be what the range of the inverse function was. All right, so that is negative 3 to 0, positive infinity. And the range is going to be the domain of the original function. So that's 0 to positive infinity. All right, so that actually tells us that we want that plus out in front and not the negative, because we only want positive results for that function. All right, and if we had a negative out in front, that would make all the results a negative.